Okay, let me just run through these two problems. So this first problem, predictions from a constant velocity graph. What they want you to do here is look at this line. So this line shows you the rate of constant velocity for this object, okay? And it's a car they're talking about. So it changes its position in meters over this time in seconds. So the slope of this line is going to get you meters per second, which is a velocity. So this first part right here, the first answer that you need to enter here, the velocity of the object, you just need to get the slope of this line. So we can use this point over here. It looks like it's at 0 time. It looks like that's 220 meters, okay? And then as I follow this up, it looks like maybe at 7 seconds, it's pretty close to 290. This program's kind of sensitive. It's a little bit above 290, maybe this point's a little better. Actually, right there might be a good one. So at 3 seconds, it's at 250. Okay, so I'm going to do rise over run. I'm going to do 250 minus 220 divided by, and that is 3 seconds. So I get 10 meters per second for my slope. So that's going to be my velocity. So over here, I'm going to enter that in, 10.0. Don't enter any units. The starting position, like I said, was 220. So again, just write numbers. And then it wants to know in this particular problem, where would it be at 86 seconds? Well, if it's traveling 10 meters every second, 10 meters per second, then to find out where it is, you just got to do velocity times time. So I'm going to do 10 times 86, and I'm going to get 860 meters. So when I go down here, 860, okay, 860.0. So hopefully these answers are all good. Let's see what it says. Okay, it says my calculations were off, so let's just see. Okay, so its true value is 10.3, mine's 10. I would accept that. 2.7% error, that's fine. Starting position 220, got that right, even though it says there's some error there. So this particular program is pretty sensitive. I would accept this only because these errors are not that far off. So as long as you're under 20% on the first two errors, and I guess based on this, if you're under 30% on the final error for predicted position, then I'll accept it. Okay, this is pretty sensitive program for this particular problem. I mean, I don't know how I would have got a better answer here, because my 10 is what's throwing off this final answer here for position. But we'll accept that one. Okay, now the other problem, graphing motion. So this graph, again, shows you position and time. And what you need to do is you have three regions. You have this red region, green, and blue. So you need to figure out what is it doing in each one of these regions. So if I hit end, right, it's going to ask for the speed in the red region, the speed in the green, and the speed in the blue. So let me return. So I just need to get the slopes. Well, this first slope is really easy in the red region because it's at the same location the whole time. So that one's 0. All right, well, this green slope, right, what am I going to do here? Same process. I need to do rise over run, right? Well, I need to pick 2 points off this line. This first point is pretty good up here because I know it's at 220. These little boxes go up by 20s, right? 20, 40, 60, 80, 100, okay? So right there at 21 seconds, the object is at 220 meters. Now, the next time that might be pretty good is right here, right? That's 32 seconds. It's at 100 meters, okay? So the slope would be 100 minus 220. It's going to be a negative answer, which is a negative slope, which is correct, right? So 100 minus 220 divided by 32 minus 21. Okay, so that slope comes out to negative 10.9. Now, this program, you're going to need to put in the negative sign, right? It's going to look for that. Now, let's get the slope for the blue line. Okay. So let me try to find some good points here. This 55 is really good because it's right at an intersection. And then 65 is pretty good too because it looks like it's crossing. So what I'm going to do at 65 seconds, it's at 580, right? Because this is 500 right here, 520, 540, 560, 580, all right? And then the other one that was good was this 400, and that's at 55 seconds. So I've got 580 minus 400 divided by 65 minus 55. So when I do that, I get 18, all right? So I'm ready to put my answers in. So the red section was 0. The green section was negative 10.9. And the red section was positive 18. All right, let's see how I did. It says my answers were good, so we can accept this one. All right, so that's it.